Okay, so what happened here is this was a question that somebody was interested in. And so it's 21 plus 7/5 increased by 5. Now the word increased means add. So I have to add this and add this and add the 5. And so let's see what needs to be done. This here probably could be made a mixed number. And so 7 divided by 5, let me, you can do it in your head or you can do it on paper. 5 into 7 is 1. 1 times 5 is 5. 2 is left over. So the answer is 1 2/5. So I'm going to write this 1 2/5. This is 21. And this is plus a 5. So I think I have it in a form that I can actually do something with. And so depending on what they wanted, and it didn't say what they wanted, I guess they really wanted the final answer. One thing you could do is add the whole numbers, 21 and 1 and 5, 21 and 1 and 5. That would be 5, 6, 7, 27. And then there's that little fraction, 27 and the 2/5. I'm not going to throw it away. I'm just going to copy it. Okay. So if that was the problem, if that was how it was listed, this is what you would do. This was a whole number. This was a whole number. This made sense to make this a mixed number. So they're all pretty much the same. And then I added the whole numbers. Remember, when you add like things. And then I also added the 2/5 not to be, not to throw that away. So that's where that problem is. What I'm going to do, I'm going to look at, I'm working with this only because I can stay on paper. But this is also in, this is the summary of chapter 1. I'm pulling the book just because it's handier for me to use it. It was all about the decimal places, ones and tens and hundreds. We'll probably find a problem like that to practice. Notice what's next, 4 words. And if I was writing a set of notes and I didn't know these words, I would certainly write these words down. Sum, difference, product, and quotient. They're telling you to add, difference, subtract, product, multiply, and quotient, divide. And so that's something that can come up. The next set are some of these properties, and they're doing it with letters. So here's commutative. A plus B is B plus A. Well, if you don't care for that, the letters, I don't care. You can just as easily say 3 plus 4 is 4 plus 3. As an example, this is a reminder that this is the commutative property of addition. I'm just going to abbreviate here. Addition. Okay. I'm going to, I think froze. Let me see if I can come back. Okay. Let me see what happened. Okay. So is that okay? And so there's also a commutative property of multiplication, which looks like this. 3 times 5 equals 5 times 3. In other words, if you It's freezing on me. If you there it is. If you multiply, it doesn't matter the order that you're doing it. Okay. And there was associative property where you'd use parentheses around the first two and then around the last two. And there was the distributive property, which looks like this. And so there's like a little delay here. So the distributive property basically said you distribute the 3 to both numbers. Okay, let's see if it'll pick up like that. So it's 3 times 5, which is 15, plus 3 times 1, which is 3. And that's the distributive property. And it's sort of acting up on us. There. It's almost like there's a delay, like we had to go from Canada to Maine to back here. But this one is the distributive property. You multiply the outside number by each number inside. And then of course you could add them if there was more to do, okay? The other thing I see in chapter 1 is 2 formulas that have to do with rectangles. And so what I want to do is, do you remember the perimeter formula? And do you remember the area formula? So what's happened is I wrote this down and it doesn't want to cooperate. There. So what are the 2 formulas? Let's say this is 10 and this is 6. So this is something you definitely need. If they say perimeter, let's call this inches and this inches. What's your answer?
Let's see.
32.
Right? Let's see. We would have 10 here and we would have 10 here. We would have 6 and 6. So we would actually have 2 of the 10s and 2 of the 6s. That would be 32.
Square.
Is it square for perimeter?
No.
Oh.
No.
Area is squared.
This is why we're doing this. So the formula is 2 of the lengths and 2 of the widths. That's pretty much what we did. You don't have to remember the formula because all you have to do is add around the edge. Because it's a definite, it's a regular figure. And so there's 2 10s and there's 2 6s. And so it'd be 32 inches. But area, the formula is length times width. So it would be 10 inches multiplied by 6 inches. This is 60 what?
Squared.
This is something you're going to be asked to do. 60 square inches. Because literally the measurement is in squares. So if this had 6 going this way and it had 10 going that way, there would be 60 squares. I didn't do that very beautifully, but there it is. There would be 60 squares, okay? So that's where that is. Order of operation. The other one that seems to be a favorite of instructors. I don't know if I'm the same one. Which one has an answer and which one doesn't?
The 0 over 4
has Is that does it have an answer?
Can I use 0 as a divisor in any? Yeah. So
There's no answer.
Undefined.
Oh, we're
No.
hesitating here, right?
I'm sorry.
We're
3/0
hesitating.
doesn't have an
Several
answer.
people,
Zero.
I'm hearing several people say various things. So I'm not getting a clear, now you may be saying the right one, but I'm not hearing everything.
But you can't use 0 as a divisor.
You can't divide by 0. And so this is the one that's considered undefined. There is no way to give an answer to this.
Okay.
This one, on the other hand, 0 divided by 4 is 0. And so that's a little crazy thing that comes up. And the other thing seems to be order of operation. So let me just write down a few that I'm seeing here. Okay. So if you had a page of notes and you didn't know the order of operations by heart, that would be a good thing to write down on the same page. The first one is parentheses. Now, although there's parentheses here, there's nothing to do inside the parentheses, but to say, my, isn't that a beautiful 5? And so really you go to the next step, which is exponents. We can do exponents. So there's a square here, but which number is being squared? Everything?
Everything.
What do you mean everything? Is the 8 being squared?
The 5 is.
It's only the 5. The 5 is being squared, and 5 times 5 is
25.
25. Now the 8 next to the parentheses is interpreted as multiply.
Why is not the 2 inside the parentheses then?
It could have been either way.
Okay.
It could have been either way, but they tend to write it outside, and they use parentheses to define what's squared.
Okay.
And so that's that. I'm going to copy the minus. I'm going to copy the 7, but now I'm down to 3 squared, and it's only the 3 that's being squared. So 3 squared, 3 times 3 is
9.
9. Now I've got to put something here, either a dot or a parentheses, so that I'm clear these two are multiplied. That multiplies to that. The subtraction is last. So multiplication is the next. And so 8 times 25, if you think of money, and a lot of people are good with money, 8 quarters would be how much?
200.
200. Excellent.
That's hilarious because I
I
couldn't do the
know
math
it is.
without you saying
Most people-
money.
It's money. This one here, 7 times 9, you have to know that is 63.
63.
Remember the rule of 9s, it's not 70s, but 60s, and they have to add to 9. There's a minus in here. So now you're almost done. 200 take away 63 is whatever.
140.
I'm thinking it's 137, but I could be wrong. I used to say to students, if you ever see a mistake, what are you supposed to do? And the answer is tell me. Because once in a while I lose it. Okay, how is that? So that was one example. Let me try this one here. This doesn't seem quite as bad, but you can get messed up here. This subtraction is last. But this subtraction is first. And the reason it's first is because parentheses makes it first. So really, you're ignoring the rest and just dealing with the computation that must be done inside the parentheses. So 5 take away 3 is 2. And I'm going to copy the parentheses and I'll copy the 2 and then I'll copy the rest. So all I did really was bring this down. I copied the parentheses because I didn't want to lose sight of the fact that this and this are multiplied. So multiplication is higher priority than subtraction. So I'm forced to do this next. So 2 times 2 is 4. That's done. Now I have 8, and then I have subtract 4. And when there's only one step, you just do the one step and call it good. How is that? Okay. All right, how's our time? Okay, let's see. The quotient of 20 and 5 increased by 9. So this, the first word, quotient, we need to deal with it. It's a quotient of something. And when they provide you with the two numbers, then you know that goes together. Quotient means divide. 20 and 5,
A fraction.
you could make it a fraction or you could do it like that.
Oh.
Okay, either way. Either way, because it's the same thing. The word increased, I think we had it earlier, means,
Addition.
okay? I kind of like the second way better now that I think about it. So addition is last, unless there's parentheses to
It would
force you
be
to
4
do it.
plus 9.
So this much is how much?
4.
Yeah, 4. And then the 9, and now we're ready to call it. How is that? So the critical part is that first step, you know, getting it out of English, I'd say bad English, into math, good math. You see what I'm saying? All right. You don't have to pretend you like that.
I am grateful for math right now because my other 2 classes are all about language, English and humanities, and I would be losing my mind if I didn't have a class that wasn't that.
Oh, good. Well, I'll tell you, early in my schooling, I was documented with a learning disability in reading, and I never completely solved it. And so it's a weak spot. So if I read something funny and it doesn't work out, it's because it just, you know, everybody has something that's sort of they're weak at. Did it ruin my life? No. Did it mean I had to pay attention? Yes. See what I'm saying? So it doesn't really matter what the weakness is or what you have trouble with. Just tackle it, you know, and read it. For me, I have to read things several times. Fortunately, the fact that I read so slowly is a good thing in math because
Yeah.
slow reading means you're likely to get the concept, every little thing much, much better.
Thank you for sharing that.
Oh, you're welcome.
Appreciate that.
It was so funny because I was in grade school and my father, this was so unusual at the time, was so mad. He took off work and got in and went with my mother to school to say, what are we going to do about this? I thought that was,
That's good.
men never, they never took off work, ever. You know, that was very strange, very unusual, but they knew it was going to be a problem. You can see, well, I survived.
Oh,
So let's take a look at some of the problems. I think what I'm going to do is go over to, let's go over to this. Can you see it or not? Maybe not, huh?
Nope.
Okay, let me go back. Share screen. Let's see. Okay, let me try again. Let's see what we've got here. All right. So let's look at chapter 2 for a bit. And I think this is as good a spot as any. Oh, let's pick out some problems. Now, some of you may have already done these. I think everybody gets a slightly different version. This is not a bad one. I'm going to copy some of these down and then I'll do them for you. This looks like good enough to do, doesn't it?
Yes.
Okay, divided by 2/5 squared. That looks, let me hop
This
down.
one was my enemy for about 10 minutes. I
That
figured it
one,
out.
yeah.
Yes. My
Let's
enemy.
take a look. Let's just skip around and see. This one here, a family's monthly income is 2,600 and they spend 650 on food. Write the amount they spend as a fraction of their monthly income. I think that, I think we can do that pretty quickly. Let me skip and try some more. How about this one? 1 1/5 multiplied by 4 1/2. We randomly pick numbers. Oh. Well, 199.
This is so awesome, by the way.
Is this
Chapter
good?
review.
Mixed?
Yeah.
All right. Let me see what else I can find. We're just randomly. That's not too hard, but I'll do it. 3 times 3 1/6. I wonder if they get bad at the end. Let's find out. 3/4 parentheses to the 3rd power. Usually it's only 2nd power, but who knows? Let's see. Let's see what goes bad. Oh, the quotient of 21 7/4 is increased by 14. I'm going to look at these last ones. Oh, this is the one we loved. A car can travel 32 1/5 miles on 1 gallon. Remember this from last class? How far will it travel on 1/4 of a gallon? I think we'll do that one. Oh, this is the worst one. I knew it. 7/10, 17/20, 16/25, and 3/5. And they're trying to put them in order. Can you see that? Which is the smallest, next largest. Okay, here's what I'm going to do. I'm going to go back to paper. And I think, let's see. Okay, I'm going to save that. This one here. Do you remember how we did it on Wednesday? This is more realistic. You could go 32 miles and 1/5 on 1 gallon, but how far could you go if you only had 1/4 of a gallon? Now, you could do this 2 ways. One way is to just take 1/4 of this because you only have 1/4 of the gasoline. So that would work. Another way to do it is to take this and just divide by 4 because you only have 1/4. And 1/4 of 32 1/5. I think this is the most logical. This, if we had a full gallon, we'd go this far, but we don't. We only have 1/4 of a gallon. So literally, I need to do this computation. Now, it seems like, well, it'd be less than 10. Let's just see what we need to do. The word of sitting between two numbers is multiply. 32 and 1/5. This is a multiply problem. This is in good shape. This is not. I need to make this an improper fraction. So I have to go 32 times 5. This is 10 carry a 1. This is 160. Plus the 1 is 161 over 5. Okay? Is that okay? So 5 times 32 plus 1. So it's 160 plus 1 is 161. This one here is 1/4, and this is multiply. 4 does not go into this number. 4 goes into 16, but then there's this remainder. So we have absolutely no choice but to just give up and multiply across. And there's no canceling here. So 1 times 161 is 161 over 20. Now, I think we need to make this a mixed number. In general, when it's a word problem, we want to know how many miles. And if somebody said, how many miles can I go? And I told you 161 over 20, they'd say, what? We need a mixed number this time. So 20, does it go into 16? No. But does it go into 160? Yes, that would be 8. 8 times 0 is 0. 8 times 2 is 16. 1 left over. So our answer is 8, 1 left over, divided by
Oh,
20. So that's how far we can go, 8 miles. Can you get home? You wanted to know if you could make it home, right? 8 miles that's how far you can go. Okay. I think that's the best. I think that's the best approach. We only have 1/4 of the gallon, and the gallon is this much. This will get you this far. So then we turned it into one of these fraction multiplications.
I think what I was doing, then I was breaking that number down.
Well,
That was-
there's no more breaking down
I
because it didn't, see, here's the thing, and I don't want you to ever forget this. When this does not reduce, this can't reduce.
Mm.
So this is a wasted effort to look for factors that will divide this. You can see it much clearly here. So don't be thinking this is going to reduce. The only thing I could do was make it improper into mixed number. That's the only thing I could do. And I think that's what they wanted. Let me see if I can find the other page. Oh, here it is.
Professor, I had a question about on Monday when we do the problems for the test that you're going to do
Yeah.
or that we're going to take. So when we show the work, when we do the things off to the side, like, do you want that on the paper we screenshot with?
I would say keep it on the same paper, just get it out of the action.
Okay.
Because
Okay, thank you.
sometimes when you do too much in your problem, you get lost. And
Right,
so
right.
this could have been, off to the side somewhere.
Okay.
Yeah. So
Okay,
I
thank
want you to keep the problem as neat as you can.
Okay.
So, but you don't throw away anything because it's all good.
Okay.
So this one here, the quotient of 21 and this. So this is basically saying we're going to do division. And so this is 21 divided by 7/4. And this, of course, is division of a fraction. We're going to have to do something with it, but that's okay. We're getting it out of the English. The next part is increased by 14. I think we've done several already today. Increased by 14 means we would add 14 when we're all done. So the real problem turns out to be this first part. This is division, and it has to be done before you ever think to say, I'm going to add. And so the first thing we do is make these both simple fractions. 21/1 divided by 7/4. That's the first step in either multiplication or division. Make sure it's in good form. But the division has a special extra step. The division gets converted to multiplication. So the first number is never changed. The division goes to the multiplication. And I don't know if you remember.
Yep.
This
Flip the
goes
reciprocal.
to 4/7. Now, the good part about when we inverted it, that was lucky because look at what happened here. It lined up something that would actually reduce. Now, you can't reduce unless it's multiplication. But once it's multiplication, this is fair game. And I'm going to divide both of them by 7. 7 into 7 once,
1,
7 into 21
3.
3 times. So now I have no choice but to multiply across because there's no more action here. 3 times 4 is 12. Over 1 is 12. I don't think I need to write over 1 at this point. And now I better add my 14, which I didn't forget. Sometimes I forget. This is 26. How is that? Okay. All right. I'm just taking these one at a time. The parentheses is basically saying that the third power, the cube, is belonging to both the 3 and the 4. So literally it means 3/4, 3/4, 3/4. And it might be a good idea to write it down 3 times so that you don't by mistake say, well, 3 times 3 is 9 or something like that. That won't do it. There's nothing to reduce. There's no way you have matching factors or anything common. So you have no choice but to just multiply across. 3 times 3 is 9, and 9 times 3 happens to be 27. 4 times 4 is 16. 16 times 4, now I know it, but maybe you need to do this. 24 carry your 2. Okay. Now, it would be a pretty good idea when you're done to circle an answer, make it easier for whoever's grading it. But the thing is, could this reduce? And the answer is impossible. There we are, you're funny. So because it didn't reduce here, it can't reduce here. It's impossible. So this one is done, done, done. How do you like it? Okay, don't panic. This one here, this is a multiplication and neither one is in good form, ready to go. So the 3 becomes 3/1. Multiply. Multiply, what we need to do is make it a good fraction or simple fraction or whatever one want to call it. The book calls it improper. I think it's fairly nice. 6 times 3 is
9.
18, and
Hey,
1
God.
is
19,
19 over
6.
6. Now, this is multiplication, so there's no inverting here. It's all perfect. And so you look to see, can you reduce anything? And I'm looking at the 6 and the 3.
Yes.
Yes, indeed. So 3 goes into 3
Once,
once. 3 goes into 6
2,
twice. So now I've got nothing left. 1 times 19 is 19. 1 times the 2 is 2. And frankly, I don't care if you left it like this because there's no common factors. The book tends to divide it out. This is 9
And 1/2.
and 1/2. So I think probably go ahead, although you can see that this form is sometimes very useful. It's just like here, we couldn't do this problem without putting it into that form. So both of these have, are reasonable answers, but sometimes one of them works better for our computation. This one here, all they wanted you to do is make it a mixed number. I just sort of abbreviated. And so, so I'm going to divide 199 divided by 17. Okay. So 17 into 19 goes once. 1 times 17, 17. 2 left over. Bring down the 9. 17 into 29 still only goes once. 1 times 17 is 17. And when I subtract, I get 12. I know I made the right choice because when I subtracted, my number was smaller than the divisor. And so now I have nothing more to do or bring down or anything. So I'm ready to write the answer. It's 11. Remainder 12 over the
7.
divisor 17, either place. This is your mixed number. And 12 over 17 doesn't do anything. I was looking to see if it did. It doesn't. Okay. Okay, this one looks kind of, it's the same. And because it's multiplication, all we need to do is put it in good form. This is 1 times 5 is 5 and 1 is 6 over 5. 2 times 4 is 8 and 1 is 9 divided by 2. I can work with the 6 and the 2 because they would both divide by 2. So 2 goes into 2 once and into 6 3 times. And I've got nothing more. Don't be tempted by the 3 and the 9 because they're both on top. You can't take it. So there's nothing more left. So I'm going to multiply across 3 times 9, 27. 5 times 1, 5. And then I suspect you probably should do this. Now you can do this in your head. I've been showing it as a division problem, just in case you need to do that. So this is 5, the remainder is 2 over the divisor 5. That one should look fairly similar to what we just did. This was one of the problems. We did one on Wednesday with zeros at the end, and they wanted you to reduce. The very first thing I would do is divide by 10. And so now the problem is 65 over 260. You may, I think there's only going to be one more step. This ends in 5 and this ends in 0. So I can divide them both by 5. Now, if you can do it in your head, do it. If not, 5 goes into 65 once. 1 left over. Bring down that 5. 5 into 15 goes 3. So if I divide this by 5, 5 into 65 is 13. And then 5 into 260, 5 into 26 is 5, that's 25. There's only one left over. I bring down the 0. 5 into 10 is 2. Okay. So 5 goes into 260 52 times. Now, my question to you is, could this possibly reduce? This beam of light has to do with the curtain near my window. All right. What do you think? Do you think I could reduce 13 over 52? Well, maybe not. There it is.
Yes,
You think so, huh?
yeah.
The only number that would divide this would be a 13. Right? Because 13 is prime. So if I could divide both of them by 13, I'd be good. Let's see if we can. So does 13 go into 52? Let's see. 4 maybe? Whoa. 4 times 3 is 12, carry a 1. Ha! 4 times 1 is 4 and 1 is? It does go, right? See, when the numbers get harder, everything gets a little tricky. But the only thing that we needed was the 13. The 13, if we can't use 13, we can't use anything. So 13 goes into 13 one time. 13 into 52, we just figured out was 4. Okay. So that wasn't too bad doing the canceling method, but we could have prime factored it. That was another approach. I see our time. I'm always pushing over time. I had this one problem. If you want to stay, the first thing I see is this addition is last. And so what I need to do first is the squaring. I think it won't be too bad. 5, 6 times 5, 6. Okay. And nothing cancels. So this is actually 25 divided by 6 times 6 is 36. So I'm going to copy the rest of that problem. I'm then going to put my plus sign, knowing it's last. This now is 8 divided by, I have 2/5 times 2/5. So now what? 2 times 2 is 4. 5 times 5 is 25. This problem is much improved by getting rid of those squares. In fact, I'm going to try to move it off the screen if I can. I've got to do this division and this division, and then once I get a final answer, I'm going to add it together. So this is 25 over 1. This will be divided by this number. And because of our time, I'm going to go ahead and invert it. This is multiply by, what is it? Because it's division, that has to
36
turn.
over 25.
36 over 25. Oh, I love that.
Mm.
Ah,
Plus 8 divide.
8 over 1.
Oh yeah, times 25
Time.
over.
I got to do this one. 25 over 4. Oh, somebody was thinking when they made this problem. So then the 25s cancel. I have no problem with that, do you? So then 1 times 36 would be 36. This 8 and 4 look good to me. I'm going to divide by 4. 4 goes into 4 once and into 8
Twice.
twice. So now it's 2 times 25 over 1. 2 times 25 is 50. So this holy mess turned into 36 plus 50, 86. Okay? So the whole thing is, this is order of operation. We had to deal with the squares first. Then we had to deal with the division. We had to invert that second number. We canceled anything that would cancel, and then we had our final answer. How is that? And it's good? All righty. Well, I'm gonna, let's see. Somewhere or the other.